Oh, great. Everything's just working. I love it. Hi, everyone. Oh, I'm sorry, they put me first, and so therefore it is my moral responsibility to get you all excited for these 2 days. So let's try that again. Hi, everyone. That's much better. My name is Vaidehi. I'm really excited to be here. This is my first time at RubyConf Australia and first time in Australia. So thank you. I will take all cheers and woos for the next 35 minutes. They're greatly appreciated. This is a brand new talk, so it's always a little nerve-wracking, but I love Ruby conferences, especially single-track ones, so I'm hoping that you all will like this. So a little bit about me. Our very kind MCs sort of talked about this a little bit, but I work at Dev. We have some really great content for developers, where we build community for software developers. So if you're interested in really cool technical and non-technical content, you should check us out. We're also hiring, so you should come chat with me about that afterwards if you're interested. And I have some Dev stickers, so that's another reason to come talk to me afterwards if you like stickers. I also do a couple side projects in my free time outside of work. I won't go through all of them. Maybe you might have heard of some of them. I have stickers for these too, so you should definitely come talk to me and get stickers for this. I basically just want to make friends, and that's why I bring stickers to conferences, so that people will talk to me. But outside of work and outside of these side projects, what I really love doing is learning how stuff works. Specifically, I like digging into why things are the way they are. And the thing that I've sort of been diving into recently is the internet. I know, I like to pick really small topics. This is not big and expansive at all. But what I've been learning about recently is what the internet is built on. And it's built on a lot of different things. As software developers, we don't always think about the physical aspects of what the internet is powered on. Sometimes all the physical aspects of it are out of sight, out of mind, because our jobs can feel really intangible. But those physical things do exist. There are fiber cables under the ocean, there are cell towers in very remote locations, and they're there even if we don't think about them all the time. And recently what I've been thinking about is the physical aspects of all the data that we store on the internet. Everything that we put on the web is stored somewhere. But how many of us actually think about this? I guess that most of us don't. I certainly didn't, until recently. And I want to tell you a little bit about what's going on in that side of the tech sector, because it's pretty fascinating and eye-opening. So all of the data that we create, every single time we make an API call or save to a database or update some record somewhere, it is stored and lives in a data center somewhere on the planet. So it used to be that you would be able to store your data anywhere, like in a room. People who are veterans in the industry might remember server rooms. They still exist, by the way, in a few places. But you used to be able to build your own server racks and put them in a room and have your own localized set of servers. But the reality is that those are really hard to maintain. They're not really super easy to build either. And so that's where data centers came about. They became a solution for this problem. We can think of data centers as sort of like one very large server room. It's just a big building where the sole purpose of this building is to house servers and all the hardware associated with them. And there are some companies out there that choose to build their own data centers because they get more control and security sometimes by doing that. But that's also kind of expensive, and it's not always the best option or even feasible for everyone. So there's another option: cloud services or cloud providers. And these are basically companies that rent out their data centers and the space inside of them to other entities. And you probably know about some of them. The largest by size is AWS. That's followed by Microsoft's Azure, and then Google's cloud platform, and there's also Alibaba, which is, I think, the fourth largest in size. More and more companies and individuals are switching to using cloud providers, and they're storing their content in data centers that are hosted by these services. And when you do this, you get a couple benefits. You don't need to maintain that hardware yourself. You don't really need to think too much about the network. You get better hardware and some other security benefits like distributed databases and backups. And sometimes hosting with a cloud provider proves to be more efficient. In a 2014 assessment, the Data Center Efficiency Assessment, the findings saw that typical cloud providers achieved about 65% utilization of their servers on the cloud. And this was compared to 15% utilization of on-site data center servers. So just looking at these numbers seems efficient. This also meant that when a company switched from hosting their own servers in a data center to something that was provisioned by a cloud provider, they actually used about 1/4 fewer servers in total. And there's more data that suggests that people are migrating in that direction as well. A Cisco report found that in 2016, 88% of data centers and data center traffic was filtering through the cloud and cloud providers. And this was compared against their estimation of 2021, next year, when they expect that 96% of all data center traffic is going to go through the cloud. And most of us are probably doing exactly this, too, whether we know it or not. In fact, in my now 6 years in software, every company that I've worked with has stored their data on AWS or has used Heroku, which uses AWS. And I never even really thought about what that meant for the projects that I was working on and all the data that we were collecting and storing. And based on all the data I've shown you so far, it seems efficient to do that, right? It seems good. It seems better than building your own data center. But the reality is that it's a bit more complicated, because when you start looking at what's going on at these data centers, you might have a different perspective. When you put your data in a cloud provider, in a cloud provider's data center rather, they make you sign this thing called an SLA, which is short for a service level agreement. And what that SLA says is that the cloud provider is basically guaranteeing you operation. And it's sort of like a lease agreement where they're the landlord and you're the tenant. And one of the things that this SLA will often say is that the cloud provider is going to promise little to no downtime. But how do you actually do that? What's the reality of promising no downtime? Well, data centers have to make sure that their operations are reliable, and they have to think about things like redundancy, so that your app and every other client using a cloud provider doesn't lose operations if that data center goes down. But something else they have to think about is, on a very baseline level, making sure the lights stay on. But you need the lights to stay on to keep the servers on, but servers also emit energy. They release a lot of heat. And if they overheat, then they fail. So not only do these data centers need to keep the servers running, they also have to cool these servers. And they do that by removing the hot air in a data center and supplying cold air. But this also takes energy. It's not as simple as making sure the lights stay on and the servers are working. It's also making sure that the servers stay at a certain temperature. So in the grand scheme of things, what does powering all of these data centers actually look like? Well, let's take a look at some data. Before I go any further, I just want to preface this with a very large caveat that it is very hard to find data on this topic. So I have done my best to show you a range of numbers, or I've picked the most conservative data and estimates that I can find, but it's just hard to find consistent statistics. So just keep that in mind. Data centers worldwide use approximately 200 terawatts a year when it comes to energy. For context, 1 terawatt hour is equivalent to 1 trillion watts of energy consumed in 1 hour. Now, when I read this, I was like, that means nothing to me. I don't even know what 1 watt hour really means, to be honest. So to give you a little more perspective, 200 terawatt hours is more than the energy consumed in an entire year by a few countries. The country of Iran uses less than this, and the United Kingdom also uses much less than this. Scotland has a population of approximately 5 million, and they only use 25 terawatt hours nationally in a year. And data centers worldwide are using 200. Overall, what this means is that data centers demand somewhere between 1% and 3% of the world's electricity, which is not nothing. Our entire sector, the information and communication technology sector itself, accounts for 2% of greenhouse gas emissions. Another way of thinking about this is that our sector has the same carbon footprint as the airline industry. Now, looking at these numbers, you might have had the exact same thought that I had. Why? Why are we causing such a large footprint? And what is it that is causing this to happen? Well, as far as data centers go, the answer has to do with where they get their energy from. The electricity used by cloud providers to actually run those data centers, which they've promised that they're going to continue operating with their SLA agreements, that can come from many different places. It really depends on the energy flowing into the power grid. And unfortunately, many data centers are relying on power grids that use fossil fuels, which cause greenhouse gas emissions when they're used as their primary energy source. Now, some cloud providers are more self-aware than others and are actually making strides to change this, where other cloud providers aren't doing as great of a job. So there's this great white paper that was written by two wonderful folks in the industry, Paul Johnston and Ann Curry. And this white paper goes into a lot of detail about all the cloud providers, actually specifically 6 of them in a lot of detail. And they gave them grades on how they're doing. I definitely encourage you to look at this white paper in depth later, but I want to look at a few of these in a bit more detail. The one that we'll start with is the one that I know really well, AWS. It's the largest cloud provider, and they've actually made a commitment to go 100% renewable. But they haven't actually set a date on this goal. So Your guess is as good as mine as to when that is going to happen. AWS has quite a few different zones that you can store your data in, but there's only 5 that are carbon neutral. So what does that mean? It basically means that if you store your data in a carbon neutral zone, AWS will offset your server's emissions. And the way that it does this is by buying a carbon offset. That basically just means that they're purchasing renewable energy from somewhere else and putting it back into the electrical grid. It doesn't mean that they're not causing greenhouse gas emissions. You can sort of think of purchasing an offset as a way of balancing out the emissions that you're putting out into the atmosphere. But it's not really a great long-term solution because it doesn't remove carbon emissions. It just sort of slows it down. So that's an important thing to know. The other thing to know about AWS is that they're not very transparent about what they're doing. They don't really publicly report data on their current energy use or the rate at which they're growing. This lack of data makes it really hard to know if the renewable energy that they're purchasing as carbon offsets is actually offsetting the amount of energy that they're using. I looked and I couldn't find this number. But the story gets a little worse if you start looking at a couple of their regions that are not carbon neutral. Specifically, US East 1. Now, this is a region that is located in Northern Virginia in the States, and it's a bit infamous because a lot of the times when there are big outages, it's because something happened at one of the data centers in US East 1, and a lot of companies use these data centers as their primary form of storage. The trouble with this particular region is that the power supplier in this state, in the state of Virginia, is Dominion Energy, and they have explicitly chosen not to invest in renewable energy, and they've actually doubled down on fossil fuels. So by proxy, what this means is that all the data centers in this region are contributing to greenhouse gas emissions because they're using Dominion Energy as their primary source of power. So despite having this goal of being 100% renewable, Amazon has all these data centers in US East 1, and since 2017, they've actually increased their operations in this region by 59%. So I'm honestly not sure how they're going to hit that 100% goal, but maybe that's why they didn't put a date on it. Now let's switch to Microsoft. Microsoft's cloud provider is called Azure, and they are trying a different approach. They have something called the carbon fee model internally, which basically means that every single business unit inside of Microsoft is charged a fee based on the carbon emissions of their operations. And this includes data centers. So that's kind of cool. The other thing that Microsoft has done is invested in renewable energy and also sustainable energy projects and technologies. Since 2014, they've been powering 100% of their energy consumption through renewable energy. And this is a little bit unlike AWS. They don't purchase carbon offsets. They purchase something called a renewable energy certificate. In my opinion, this isn't as good as a carbon offset. While a carbon offset represents a reduction in the greenhouse gas emissions, a renewable energy certificate just represents a certain quantity of renewable energy that you're purchasing. So maybe there's some room for improvement there. Microsoft also recently announced that they have this plan for 60% renewable energy to power their data centers by the end of this year, 2020. But again, they haven't been entirely transparent about how they're going to do this, despite this promise. It's still not really clear, if you go looking for this information, which regions in Azure are powered by renewables versus which regions are being offset by those renewable energy certificates. Now Google, if you look at Google, things get slightly brighter. I don't know, that might be the first time anybody's ever said that, but the Google Cloud Platform buys carbon offsets for all of its servers, not just ones in a specific region. In fact, Alphabet is the largest corporate buyer of renewable energy, hands down. And Google has talked a lot about the challenges that they've faced in terms of getting 100% renewable energy to be able to actually operate those servers that they have. And they've talked about how hard it's been. So one of the things that they've tried, which I think is really interesting, is for every single kilowatt hour of energy that they consume, they purchase a matching kilowatt hour of clean, renewable energy and add it back to the power grid. So even though Google Cloud causes carbon emissions, they're actively offsetting everything that they're adding to the atmosphere. And this basically means that Google is the leader of all of these four cloud providers that I am going to talk about today. They're doing better than most, honestly. And Microsoft is the only other cloud provider that has actually met that 100% sustainability goal. Now, unfortunately, I can't talk about all the things that are going well without talking about the things that aren't. Specifically, I have to tell you about the other cloud providers that aren't doing a great job, especially the ones that are based in China. So last month, Greenpeace released a report that was tracking the state of renewable energy in China's tech industry. And researchers estimate that between 2019 and 2023, the amount, the data center industry in China is going to increase by an amount of up to 66%. And this is important because at present, most data centers in China are powered primarily by coal, which again is a fossil fuel that is contributing to greenhouse gas emissions. In that report, 50% of the companies that were analyzed claim to purchase renewable energy or to relocate their data centers to be closer to renewable energy sources. One of those companies that has this claim is Alibaba. But the problem with them is that they also have made very small steps towards purchasing renewables, and they have not been public at all with their data. It's very hard, actually, I couldn't find any information around their greenhouse gas emissions and how much energy they're actually using currently. So without going into any more detail about any of these providers, even though, trust me, I could, there's a lot of information out there, now we know a little bit more about the reality of what these data centers are actually doing. So the question now is, how is this going to scale into the future? Are we doing enough? Well, talking about the future of data is a little bit hard to do because there's even more disagreement around these statistics. Some researchers just really disagree about being able to predict what's going to happen. But here are some things to consider. One of the side effects of using a cloud provider is that it's really easy to just increase your usage. It's pretty easy these days to provision a new server if you have an uptick in data or traffic. So we can imagine, if it's super easy to do, how that might cause things to scale. We can imagine how it might impact data center traffic over time. Another reality is that global data traffic is growing quite quickly. According to a research paper released by Cisco in the Journal of Industrial Ecology, global data center traffic increased 5-fold between 2010 and 2015. The researchers who wrote that paper also estimated that approximately 28 billion devices are going to be connected to the internet this year, in 2020. Now, the International Energy Agency published a report in 2017 just looking at the number of IoT devices. In 2017, there were 18.4 billion IoT devices connected to the internet, and they estimate that that's going to grow to 20 billion this year. The same report by the International Energy Agency found that the total global traffic in 2017 was likely going to surpass 1 zettabyte. And they guessed that by 2022, that number would hit 4.2 zettabytes. The most interesting thing about this data for me is that after zettabytes comes yottabytes, which is 10 to the power of 24 bytes. My brain cannot fathom what that is, but that's cool. Technology is going to continue to demand more and more energy. Now, this graph is just showing an expected case projection. Remember that I said it's really hard to estimate how this is going to scale over time. But in the expected case, our sector is going to demand approximately 21% of the total global electricity demand by the end of this decade, in 2030. So given that we're an industry that thinks a lot about efficiency and scalability, and we're always asking people in interviews about big O notation, we should probably think about this problem. That's the thing that we like to do, right? How many of us have actually thought about this? Well, I do have some good news. Some of us are thinking about this problem. For starters, more and more companies are investing in building new data centers in colder climates, which sort of offsets the amount of energy you need to take to cool servers. So that's a start. In 2018, a data center called Digiplex, based in Sweden, began using a really interesting indirect evaporative air-to-air cooling technique. And this solution was implemented in the data center buildings. And basically, what this allowed them to do was recover wasted heat that was just excess heat from the servers, and they repurposed that and used it to heat over 10,000 apartments in Stockholm. So that wasted energy wasn't wasted after all. A few years ago, very close to where I live, the Oregon Health and Sciences University built a data center that was covered by this geodesic dome, and it was made of aluminum. And I don't know, insert something about physics here. I don't really understand how it works, but apparently it used natural convection to help eliminate all the cooling equipment that data center needed. So they actually got rid of their exhaust fans and their air conditioning units, and they saved money on electricity costs too. Stripe, which actually doesn't have data centers of its own, it uses AWS, I think, it decided to dedicate itself to becoming carbon neutral. And basically what they did is buy enough carbon offsets to reach net zero emissions, and they hit that goal by 2017. And there's also just people in our community who are doing a lot to try to bring light to this topic. Those two authors that I told you about who wrote that white paper, they created a petition called the Sustainable Servers by 2024 petition. And you can see that there are a lot of people already signing it. I encourage you to sign it if you feel compelled. And they're planning on using all of this to lobby cloud providers to invest in sustainable energy sources. But it's not just researchers and designers and companies who are capable of doing things in this arena. Each of us has agency in solving this problem too. One of the biggest problems with storing data in the cloud is that it's just not easy to figure out where it lives and whether that area is clean or not. So the first step that all of us could do is figure out where your data lives. Is it stored in a region that's carbon neutral, or is it stored in a place that's contributing to greenhouse gas emissions? Given how hard it can be to find data on this could just be a hard question on its own to answer. There's a great website called the Green Web Foundation that can help answer this question about your own projects and about just generally any app or website that you use. Another thing that all of us could do is migrate our data to a green region. Now, admittedly, if you've ever done a data migration, you know that this is a big ask, and I understand that. But it is something you can do, or at the very least, you can start talking about doing it. And if you're in the lucky position that you're starting a project fresh, you could provision servers that are located in a carbon neutral green location from the get-go. Another great step you can take is to just draw attention to this and talk about it. At my last company, I found out after reading some of this that we were storing our data in US East 1, and I was pretty horrified. So I just brought it up to the team, and we had a conversation about it, and we at least started talking about what it would take to migrate off of US East 1. Hopefully they will actually go ahead and do that. That would be awesome. So if you're at a small company, that just might mean talking about the issue internally. But if you're at a larger company, especially one that has an enterprise account with any of these cloud providers, you can pressure your cloud provider to be transparent about where they're storing your data and how they're getting their energy from. And if you're hosting with someone like AWS, you can talk to your AWS account manager and tell them that you want more renewable options. Apparently, account managers really listen to their customers, so there's that. But beyond that, if you work at a company that provides cloud services, and if you have the power and the privilege to do so, you can do even more. There are some really amazing employees at Microsoft and Amazon that are already doing this, and you might have heard about it in the news recently. I think that's really awesome. And if you're really motivated, you can also build things to help make this data more transparent and to stop hiding this information from not just us in this industry, but from people outside of it too. You can make it really accessible. A great example of this is the Cloud Sustainability Console, which is a Chrome extension that I found that is pretty simple. All it does is highlight which regions in the AWS dashboard are green. But this does more than what Amazon's doing, so 2 thumbs up in my book. Super helpful, super informative. But if you take nothing else away from this talk, I hope it's just that you'll be aware. There's a lot of physical implications, tangible implications of the work that we do every single day. And ultimately, I don't really think that there are any easy answers here. But I do think that we have a responsibility to take the first step, given the privilege that we have to be in this industry. So to that end, I want to quickly thank the people who've made me aware about this problem. Denise Yu, who tweeted an amazing infographic about data centers and their energy usage, and also Paul Johnston and Ann Curry, who wrote that white paper that I told you about. They've done a lot of research on this and written a lot about this, and they help bring it to a lot of software developers. And I know that hearing a talk about climate change is kind of a downer. Now you know why I started so excited at the beginning of this talk. But the reality is that we're using a finite resource, whether we realize it or not. We might not see it all the time or think about it, but it is happening. And as I've learned more about this topic, and I've learned what it takes to store data on the internet right now, I don't even think we as an industry understand the cost of it. I think there's a sticker price on it that we don't even know about yet. And even though I've spent a lot of time learning about this, I actually don't feel entirely disheartened. You see, it might seem like all we're doing is contributing to the problem, but there's another way to look at it too. Our industry has historically done a lot to push things forward. Admittedly, sometimes we mess up, and sometimes we're not checked that well. And it's a little bit like the wild, wild west out here. But we have pushed the needle forward and set really good examples for other industries. And the thing is, other industries are going to face this same problem too. They are facing it right now. So in the end, I'm actually optimistic. I'm optimistic that we can set a good example again. I'm optimistic when I see people in our industry who are already doing things to try to change the status quo. They're trying to design better solutions, which makes me hopeful that we can set a great example. The thing is, none of us in this room are just consumers of technology. We're actually creators of technology, which means that we have a voice in this too. So the only question that I think is left to answer is if you'll use it. Thank you.